So this short video is an overview of a couple of topics in Chapter 3, Section 3.3 of Building Java Programs. And the two objects that we will be using are the string object and the scanner object. So the reason why these are called objects and not types will be covered in a lot of detail in Chapter 8, and we do not need to worry about what exactly is a class, what exactly is an object, but we just need to start to use some of these features, just like we've been using the math class and some of the methods of the math class by doing things like math.round, for example, and passing a number in here, let's say 3.78. So we've been using this notation and also using math.py and not realizing that math is a class and it offers us some features like rounding numbers. But the way to do that is to add the dot to call the rounding method of math and use the dot to say pi to call the constant pi, which is part of the math class. So this is a notation that we will start to get very familiar with, and by using some of the other objects that are available to us in Java. Now, strings, the way we use strings is doesn't seem like we're using the dot notation, because so far we've done something like string we've done something like string word is equal to good, for example, and we don't seem, and we've concatenated strings by using good class, for example. We've done all of this stuff. We've printed strings without thinking of them as objects. But what we're going to do in this short video is we're going to see how strings can be used as objects, because they have a ton of other features that we can use, right? So let's go to, you can read the Building Java Program slides and go into details of what a class is. A class is a template that can be used to create objects like scanner, string, and so on. And an object is an entity that combines data and behavior. But let's go into some string examples here. So as you can see, I can create a string by just doing it like a regular primitive variable. String name is equal to text, string name is equal to expression, where expression is also a string. But because strings are object, I can also do something like string word is equal to new string, and then I can say good. So this is going to be a new way to define a variable. So the variable word is of type string, and the way we know that it's an object, not just a primitive variable, is because we use the word new, and we use this kind of a definition or a declaration to create word. So what this is saying is, can you create an object called word for me? And the type of the object, so this is an object, and the type of the object is of type string. That means it can store characters. So here I'm going to store good inside this object. And because it's an object, it has data, and the data is this one, is good. And I can also do some actions on this, so invoke methods on it. So what are the methods that I can invoke on this? The methods I can invoke on this are, for example, I can do something like word.length. And this will give me the number of characters, the counter characters. So 1, 2, 3, 4. So this is going to be equal to 4. Now see the way that I'm actually using calling the method length, I use the name of the variable and then I say dot and then I invoke a string method. I can also do something like word dot substring and then I can say 3. If I do that, then what I'm saying is, can you slice the string for me and take a piece of it starting from position 3. Now, what is position? Now, when you have a string, we are going to start giving a position to each character. So the first one is position 0, the second one is position 1, the second one is position 2, and the last one is position 3. So these numbers are called indexes, and they're used to indicate the position of a character inside the string. So it's all linearly ordered, and so G is at 0, and note that it's the numbering starts at 0 and then it ends at n-1, where n is the length of the string. In this case, if I say substring 3, then what's going to happen is that it's going to take a piece of the string starting at 3 and going all the way up to the end. So this doesn't stand for the number of characters that you want to slice, but it stands for the position. And therefore, what I will just get out of this is the string containing just one single letter called D. And of course, what I can do is I can do things like string small equals word dot substring 3, and this small is now going to, if you print it, then small is going to be equal to D. So I perform an action on this string called word, extract D out of it and save it in small, right? In a similar way, what I could do is I could do something like integer L equals word dot length, and then L will contain the word L is going to contain 4, because 4 is the length of the string. So these are ways to do actions on the object, which is word. So word is a string object that's got created. Here's a little bit about indexing. And so you see here in this example, I've just created a string called name and not used the object notation. I could have completely done it in this way. Name is equal to new string r.kelly. I could have done it this way, right? Both ways are absolutely fine. So string is a little bit of a special object in that way. And look at the indexing. So let's start with 0 and go all the way to 7, because this string has got 8 characters. And then, so if you place it inside the box right underneath the numbers, you will know that K has got index position 3. The last element has got index position 7, and that's why the first one has got index position 0, and that's R, right? And each one of these is an individual type called char. Now, here are some of the methods that you've seen just in the previous slides. That is length, which gives the number of characters in the string. The index of is very useful, because what it does is it allows us to search for a word inside the string, and it gives the exact index position of where this word is found. So for example, going back here, if I said something like name dot index of KEL, then KEL is actually a substring or a piece of string that's found inside this, and we know that K starts at position 3, and therefore if I say integer pos for position equals where does Kel start, and then pos is going to be equal to 3, because this indicates that KEL is available and it starts at position 3. If I, instead of Kel, if I said accidentally Mel, then mel is not found here, and therefore position is going to get equal to -1. And that's how we can tell if a substring is found or not. And you can also give a start position and end position of the string that we wish to extract. Now, here, the thing we have to just watch out for is if I wanted to extract KEL from this string, I could use the substring method and say, oh, can I have a string short to be equal to name dot substring. I'm just going to erase this. Name dot substring equals to name dot substring here, and then I need to start with K, so I'm going to say 3, and I know I need to stop at L, so I should actually give 5, but it turns out that the way substring works is you need to give one more, and therefore I will say go start at 3 and end 1 before 6. So this will give us KEL. This will give us KEL. It will not give us KELL. Now, if, for example, you'd like to get the entire name Kelly, then what you need to say is 3, 8. And this seems really weird because there's no number 8 position, but because it stops 1 before, it's going to get you KELLY. So that's one thing that we need to keep in mind when doing string processing. Now here, as you can see, there's some other stuff like lowercase and uppercase, and there's one thing, so the thing to watch out for, maybe we can do that in an example here. So let's take this example where we've got a string called greeting, and I've initialized it to hello there. We can print it, and here what I'd like to do is I'd like to convert this greeting to uppercase. So I use the to uppercase function and I say greeting dot to uppercase, right? And then I say, all right, that's converted to uppercase, and I'm going to print it. So let's try to compile and run it. And I see that it has not converted to uppercase. The reason for doing that is that whenever you apply a function to a string, you need to save it back in another string, right? Because it does not make any changes to the original string. So greeting.upperString is not going to change the original string greeting. So what we may want to do is we may want to create string upper greeting is equal to, so we're saving the uppercase version of greeting into upper greeting, and then we are going to print upper greeting. And now let's say, and now as you can see, it has actually converted it to uppercase. So these are some of the methods of string processing, and they're very powerful, and I would strongly suggest you go into practice it and pick out those examples. Definitely practice it, practice those string examples. Now I'd like to talk about scanner a little bit here. Scanner is another object, and as you can see, so far we've only had capabilities to print or display on the console. We'd like to make our programs interactive, and therefore we can ask the user to type input on the console. And the way to do that is to get ourselves a scanner. Now, one thing that we have to do is we have to in order to use scanners, we will do import java.util.star. Let me just change this to the top of the class. So the position of this import statement is at the top, even before you have your class class header. So I'm importing myself java.util I can even do scanner. So we can, either is right, you can import the scanner directly or import lots more stuff. So let's for now keep it to scanner. And what does the scanner do? The scanner console equals to new scanner system dot in. It creates an object called scanner, called a scanner object. Or let me change, of type scanner, called word, that reads in user input from the console. So this is what the scanner does. Now scanner can also read from files. It doesn't have to be restricted to the console, but we will go over how the scanner can connect to a file in chapter 6. So for now, just trust Java on this, that you have created a new object of type scanner, which gets connected to the user input, because we're saying system.in as opposed to system.out, and that will give us methods to read information from the console. So how to do that? So here we can say system.out.print, please enter your name. Right, and then we can say console.next. We can say string name equals console.next. Now this, just like you've got the dot methods for the string object, you can have dot methods for all objects, and one of the methods is next, that just gets the next token from the input. And what we can do here is we can system.out.println, and we can say your name is, and whatever name the user has input. And let's just compile and run that before we run away with. So here, as you can see, the scanner is waiting for input for us. And we can enter, for example, let's say Henry, and it prints your name is Henry. We can do a little bit of string processing here, and we can say now greeting equals greeting plus the name that we have read. And therefore, we can now, if I print greeting here, it says, please enter your name. My name is Henry. And then it says, hello there, Henry. Now, I wish I had put a space there. If I put that space there, then it's going to be a little better formatted. It says, hello there, Henry. I can I can do some more processing. If I didn't want to say hello there, Henry, I just wanted to say hello, Henry, and then what I can and have yeah, that's what I could do. So I could then cut off using substring. I could say short greeting, short equals greeting dot substring. And now I need to know the index position. So the greeting is hello there. This is 0, 1, 2, 3, 4, and it goes up to the blank space is 5. So 0 to 4 would give me hello. So I need to start with 0, but I need to put 5 because it is always 1 before. So short is just the greeting which contains the word hello. And now I could say greeting equals short, let's say short greeting. Short greeting. Plus I'd like to leave a little space here, and then add the name. And now let's print this one. Instead of printing here, I am going to say, I just want to say hello, Henry. And what I get here is hello, Henry. Now, if I wanted to change all of this to uppercase, I could just go back and change the greeting to uppercase, and I would have everything go into uppercase, right? So these are some of the ways in which we can combine string processing, use string processing to make our user interaction more interesting. Now, next is not the only method with regard to the console. We can, excuse me, we can say, and say, what is your age? And enter integer age equals, we can say console dot next int, and this will input Henry's age. And now I can keep extending my greeting and say greeting equals greeting plus you are age years old. And this should, and then system dot out dot println greeting. So now I have been able to, using console.nextInt, I've been able to read an integer. Now I can also read a double by saying what is your weekly salary? And here I can say double salary equals console dot next double, and I can read that in line. So what I can do here is I can ask another question. And so what I'm going to do here, so what is your weekly salary? Read this in, and then I can say system.out.println. Wow, you earn salary per week, dollars. And then I'm going to run this one and say, Henry, what's your age? 21 and 667 point. It says, wow, you earn these many dollars per week. There's one thing though that might mess up my scanner, and I'm going to try it here. Let me say I enter Henry James, which is the full name of this person. And now you can see that scanner has gone into a problem. So scanner is into a runtime error. What actually happened? What happened was that next only reads one token at a time. And what I did was I gave two words here. So Henry got put into name, but James got put into the integer age, and that did not work. So if you'd like to read the full name of Henry, we need to do console.nextLine. So let's change that. And here now I can say Henry James because it's going to read the entire line. And 21 years old and 764.989. And this works fine. What this tells us is that the scanner reads information token by token, separated by a white space or a new line, and therefore it's important that when the scanner is reading, it reads information of the correct type. So here the type is a string, and therefore it will read a string. But the next time round, the scanner is waiting for an integer, and we need to give it an integer. If we do not give it an integer, then the scanner is going to run into a runtime error. So we have to be careful that if you'd like to give the scanner to read a complete line, then we give next line. If we just would like to read one token, then we can use next. And if we use next, then it does not matter what is the type of the token. It can be an integer type or a double type, and the scanner will all read it as a string. But if we would like to read a token of a specific type like integer, and we use next int, then we have to be sure that the user is very careful to stay with the typing. Otherwise, the scanner will not be happy and it will crash.